All right, for the last section in 4.5, we're going to be solving exponential equations and logarithmic equations, and we're going to look at some more application problems. First of all, to solve exponential equations, such as a couple wants to know how long it will take for their investment to double, we're going to be solving for the variable t up here in the exponent position. That's why this is in the section for solving the exponential equations. How do we get up there in the exponent position to solve for our unknown? Okay, one of the things you might want to do is employ this equivalence property. If you can write each side of your equation with the same base, then you can just set those exponents equal to one another and solve. Sometimes this works and sometimes this doesn't, but if it does, it's the easiest way to solve these exponential equations. All right, as an example, here on number 10, we have 5 raised to the 2z plus 2 power equals 625. Now, 625 can be written as a power of 5. Actually 5, and you might need to do just a little bit of trial and error on this, 5 to the 4th power, 5 times 5 times 5 times 5, 25 times 25 gives us the 625. So 625 can be rewritten as 5 to the 4th. On the left-hand side, we have 5 to the 2z plus 2. Since we have the same base of 5 on both sides, then our equivalence property says that if that's going to happen, then our exponents, the 2z plus 2, has to be equal to the exponent of 4 on the right-hand side. From there, it's just a matter of solving for z using a little bit of algebra. Subtract 2 from both sides. So 2z equals 2. Z would be equal to 1. Now, you can check if you would like by putting that 1 back in for z. I didn't spell check appropriately. Let's clean that up. Check. Then check. All right, and that would work out. Now on number 12, I have a base of 7 here, okay, and a base of 1 over 49 here, okay. So I think I'm going to be able to finagle this around a little bit so that I have a base of 7 on both sides, or maybe I want to have 1/49 on both sides. Either way, I think if I take this base of 7 and I try to turn that into a 1/49, let's think about what I would need to do to that 7 to get me to 1/49. Well, if I have an exponent of -2 on the 7, that actually is equal to 1 over 7 to the positive second, which would be 1/49. Okay, so here for this 7, if I put in for that the 7 to the -2nd, all right, that's going to be the same thing as 1/49. Let me see, so 7 to the -2nd and then raised to the 2x minus 3, let me leave that there. I think I'm messing this up. Hold on. Okay, yeah, I really think what I would rather do instead of this is kind of I don't know, messing me up. It's kind of confusing me a little bit. I think what I'm going to do here is instead I'm going to say that back over here that this 1/49 is actually the same thing as 7 to the -2nd power. And I'm going to put that in right here, 7 to the -2nd power. That way I'm not changing anything, okay? That is the same thing as 1/49. Now that is being raised to the x plus 1 power. And then I'm just going to bring down the left-hand side, 7 to the 2x minus 3, okay? Now, what I need to do on this right-hand side, because I've got a power raised to a power, and anytime you have a power raised to a power, the rule is you multiply those exponents. Well, to multiply, I'm going to have to use my distributive property. All right, so I'm going to bring down the left-hand side of 7 to the 2x minus 3. On the right-hand side, that simplifies to be 7 to the negative 2x minus 2 when I run the negative 2 through. Okay? Now I have the same base. I'm going to set those exponents equal to one another and solve from there. All right, first of all, let's add 2x to both sides. That sounds good to me. Then we'll add 3 to both sides, and we will get 4x equals 1. All right. So x is 1/4. Now again, you could plug that back in to check to make sure you get the same thing on the left-hand side as you do on the right-hand side. But that is how we're going to solve these exponential equations, by using our equivalence property when we can write these as the same base. Okay, we can do a little trickery to write those as the same base.